Hello students, I'm making this video for how to use virtual lab of basic electronics engineering. So first question arises in your mind is what is virtual lab? So virtual lab is basically the platform provided virtually by MHRD. It's a Ministry of HRD department. So what is virtual lab? It is an experiment with the experiments remotely from anywhere and anytime. That means you can sit at home and you can perform the experiments virtually. You can check the result, you can check the output virtually. So there are some features and advantages. I picked few of them. So it's a free to use, no need to pay any cost here, any money here. You need an internet to access this virtual platform. It's safe to operate. There is no any risk to perform the experiments virtually. And it is available in all areas of science and engineering. That means you can search it, you can find the different subjects available for this virtual laboratory. And this is really important, freedom to make mistakes. So you can make mistakes and you can correct it multiple times. This is not happening when you are performing practically experiments. It may damage the components, hardware components. So that's why it's a freedom to make mistakes. So let's start how to use this virtual lab. Okay, browse. Simply you have to type virtual lab. Enter. So you'll find the first site, that is a www.vlab.co.in. Click there, and now we will have you will find the page of MHRD. It's a virtual lab platform. Just scroll down. Here you can see there are broad areas of virtual labs. So basic electronics engineering comes under the electronics and communications category. So click here. Scroll down, you will have the different subjects available here. Go to basic electronics lab, IIT Kharagpur. Click here. You will have the basic electronics virtual laboratory page where you will have the different tabs available. So introduction, list of experiments, instructions, technology used. So go to list of experiments. I'll show you one experiments here. So there are total 17 experiments available to perform virtually. Out of that, I'll show you the VI characteristics of diode. So as like your actual practical theory part, you can see, you can study to understand, to perform the practical or the experiment. First you need to read the theory thoroughly. So what is theory? So theory of p-n junction diode is here. Here the objectives, why you are going to learn or perform this experiment, structure, function, both type of biasing available, reverse biasing and forward biasing. Out of that we will study forward biasing today. This is the VI plot, VI characteristic curve. So ideally should appear like this. That also we are going to see. Okay, these all are theory parts available here. So first you need to study it, you need to learn, you need to read theory thoroughly. You go to procedure. Here you can see all the procedure is here. Right from first step, what you need to do. So select DC voltage to 0.2 volt. Okay, that point we will see. And all other part, procedure part is here. And then simulation. So simulation is nothing but your through simulation you are actually performing the practical, you are actually observing the output in the simulation part. So click on simulation. Here you can see there are different characteristics, characteristics of diodes are available in different modes: forward bias mode, reverse bias mode of silicon diode. So I'll show you how to perform virtually. So small experiments we'll study today, that is a forward biased silicon diode. So click here. So in this page you can see instructions, experiment table, this is your actual circuit diagram, and these are the controls. See, instructions are here, you have to just follow one by one all the steps you have to perform here. This is your experiment table, is nothing but your observation table. Circuit diagram, it consists of resistor here, DC voltage apply, you have to apply the DC voltage here, 1 ampere, and 1 voltmeter is here, and these are the controls. And once you apply the input, you can observe the output in this graph plot. So basically in this experiment we are going to plot the curve of voltage versus current, VI characteristic curve. So let's start. So go to control, select 1N4001 diode. So by default it will give the VF, that is forward voltage, it's a 0.6 volt. You have to apply DC. So what you need to do here, you have to take the multiple readings of the input, that is nothing but DC voltage. So initially I am making it to the 0 volt. Here you can see it's a 0 volt. And now this is the resistor. Okay, you can set it to 1000, that is 1 kilo ohm, around 1000. Okay, 1009, it's okay. And now let's start. First, here you can see that there are 3 options available: add to table, plot, and clear. First you need to take the multiple readings. You have to take one by one and you have to add it to the table. It will come here in this experiment table. So in this way you have to take a minimum 10 readings in this range and add it to table, and then we are going to plot the curve. So let's start. So my first is DC 0, resistor 1000, and click on add to table. So first reading will appear here. First reading is what, 0. Now what you need to do, you have to increase the voltage, vary DC voltage. Still you can see the instruction, vary DC voltage little bit. Okay, so it is now 0.533. Now add it to table. Yes, second reading, then third reading, fourth reading. So in this way you have to take the multiple readings. So minimum 10 readings you have to take, but you can take the maximum number of readings here to get the smooth curve in this VI plot characteristic curve. For that you have to take the maximum number of readings in this range. Okay. So let's see how many readings are there now. 15 readings. Yes, so this is our observation table. We have applied input voltage, we have measured forward voltage as well as a forward current, and these units are here. And now you can see still there is no characteristic curve. So what you need to do is click on plot and it will generate the VI characteristic curve. So it is here. So voltage versus current, and you can just match it to your theory part. So ideal curve. Yes, so this is the ideal curve. You can see it appears same here in this virtual practical, right? So in this way you can perform the other experiments in this virtual mode. Thank you very much.